Hi, good evening. Good evening, all. Shall we start? We have worked out till question number 9 in exercise 7.3. So we have to continue from question number 10. How many of you have worked out yesterday? Did you find any difficulty in working out or any doubt? So we have to work out from 10th question, exercise 7.3. So question number 10, I equal to, if you can't see clearly, let me know so that I can adjust the screen accordingly. Yes. So I equal to sine power 4x dx. I hope you remember the formulas yesterday we have discussed, isn't it? So, how to solve this question? How to solve? Yes, sorry. So, can we write this sine power 4x as sine square x the whole square? Yes. And now, yesterday, like in the last class, we have discussed certain formulas, right? Like from how we are using those formulas. So, sine square x. So, we know 2 sine square x is 1 minus cos 2x, because 1 minus 2 sine square x is cos 2x. Swapping the terms as we need this, taking this into 2 to the right side as by 2. So sine square x can be replaced as 1 minus cos 2x by 2. And so we can write this as, so using this formula, we are writing this I as 1 minus cos 2x by 2 the whole square, because inside for that sine square we have replaced using this formula, but already we have outside the whole power 2. Now using a minus b the whole square formula, you have to expand the terms, and denominator we have by 2 as a common. You can take it as 1 by 4 because it is also a whole square, yeah. And now a square minus 2ab plus b square into dx. And now we have to use the formula 2 cos square x, like how we had 2 sin square x. Similarly, we have the formula that is 2 cos square x equal to, what is the formula? Any guesses? Any guess? Very good, Nikita. 1 plus cos 2x. So now cos square x equal to, into 2, take it to the right side as by 2. So 1 plus cos 2x the whole by 2. That we will replace here in place of cos square x. So we just split the terms here. So 1 by 4 into 1 dx minus, I'm just taking this 2 outside of the integral. So that will become 2 by 4 integral cos 2x dx plus 1 by 4 integral cos square x. We have to replace the formula. Here if you see, we have cos square x. But what we have here? Cos square 2x. So for that, cos square in place of x, we have 2x. So what we have to do in the right side? In place of x, we have to replace it as 2x. So what we get? Instead of 1 plus cos 2x by 2, we got here as 1 plus cos 4x by 2, as we have cos square 2x. Is that clear? Now integrate. Integrating dx is x and by 4 we have, and here this gets cancelled, so we have 1 by 2. Integral of cos is sine and coefficient of x is 2, so we will write it as sine 2x by 2 plus, here we have replaced the formula and take this 2 outside, so we have 1 by 8. Integral of dx is x, integral of cos is sine and coefficient of x is 4 here plus c. So this can be written as x by 4 minus sine 2x by 2 2s are 4 plus multiply this 1 by 8 inside. So I will get it as x by 8 plus sine 4x by 4 8s are 32 plus c. This is the required answer. Any doubt? Can we move on to the next question? Should I repeat anything here? So question number 11. Cos power 4x. Instead of cos power 4x, we have it as cos power 4 2x. That you take it as I as usual. The same process. We are replacing this cos power 4x as cos square 2x dx. And what is the formula we have substituted here? The same thing. Cos square 2x irukku illaya? So we have cos square 2x the whole square, and for cos square 2x only we have derived the formula here, that is 1 plus cos 4x by 2. So replacing here 1 plus cos 4x by 2 the whole square. Use a plus b the whole square, and I am taking this 1 by 2 square as 1 by 4. So a square plus 2ab plus b square, so that is cos square 4x dx. Now I am just writing it in the terms. I am just separating the terms here. So 1 by 4 integral 1 into dx. I am taking this 2 outside. So 2 by 4 integral cos 4x dx plus 1 by 4. In place of cos square 4x, what we got for cos square x? That is cos 1 plus cos 2x by 2. And what we have here? 4x. So replace this x as cos square 4x. So right side what will happen? In place of x it is 4x. So cos 2 into 4x, because we have 4x in the question. Now that 1 plus cos 2 of 4x will become 8x. So 1 plus cos 8x by 2 into dx. Now integrate. So we get integral dx is x by 4. Here 2 and 4 gets cancelled. So 1 by 2. Integral of cos is sine. Coefficient of x is 4 here. So when you multiply 1 by 4 inside, and already 2 is in the denominator part, so you'll get 1 by 8 integral of dx is x. Again 1 by 8. Integral of cos 8 is sin 8x and coefficient of x is 8 plus c. And now can you see? Yeah. So what will be the final answer? X by 4. 2 4s are 8. So sin 4x by 8 plus x by 8 plus sin 8x by 8 8s are 64 plus c. Either you can simplify these two and you can write the final answer, or you can take the 64 as LCM. Anything you can do. Now I'm just simplifying these two as I have x terms. So 1 by 4 and 1 by 8. Obviously 8 will be the LCM. Here you will be multiplying 2 plus 1, 3. So 3x by 8 plus sine 4x by 8 plus sine 8x by 64 plus c. This is the simplified answer. Next, question number 12. Question number 12. I equal to integral sine square x by 1 plus cos x dx. There are two ways to do this question. Either you can replace sine square x as cos square x minus 1 by 2. You can use that, or directly replace the trigonometric identity. We know sine square x plus cos square x equal to 1. Yeah? So sine square x can be written as 1 minus cos square x. And we know the algebraic identity that a square minus b square can be written as a plus b into a minus b. In place of a you have 1 square, in place of b you have cos square. So it is 1 minus cos x, that is a minus b into a plus b, the whole by already we have 1 plus cos x term. Now integral dx. So here 1 plus cos x gets cancelled. So remaining you have 1 minus cos x. So that can be written as integral 1 into dx minus integral cos x dx. So integration will be x minus sin x plus c. Already have minus, and integration of cos is sin x plus c. That is the final answer. And question number 13. Similar question. So you have cos 2x minus cos 2a by cos x minus cos a dx. So here you have to check what is the integrating variable. Since it is x, so you can treat this as the constant. That is for our additional information. Only this we will take into care. And before simplifying, we will replace the formula. Since everything in terms of x, so what we do is, we will replace this cos 2x as 2 cos square x minus 1 minus of cos 2a as 2 cos square a minus 1 by cos x minus cos a. So now remove the brackets. So we have 2 cos square x minus 1 minus of, like we will be multiplying minus inside, isn't it? So 2 cos square a minus into minus plus 1 by cos x minus cos a into dx. Minus 1 plus 1 gets cancelled. Since 2 is common, we can write, you can take 2 as common outside. Again, it's like a previous question. It is in the form a square minus b square. So you can write it as a minus b into a plus b. That is clear here. Since you have, like we have taken 2 as common, you will end up with cos square x minus cos square a. And it is of the form a square minus b square. So you can write it as a minus b into a plus b. So cos a the whole by cos x minus cos a into dx. As a whole, you can cancel this term cos x minus cos a. So we will end up with cos x plus a. So I is equal to integral cos x dx plus I am taking cos a outside because there is no x term in the argument. That is treated as constant. You can take it out. So you will have only integral dx. So integration of cos x is sin x and integration of dx is x. So x into cos a plus c. This is the final answer. Any doubt? Any doubt? Can we move on to the next question? So question number 14. I equal to cos x minus sin x by 1 plus sin 2x dx. So how to do this question? What can be done? Let's see what can be done. So cos x minus sin x we can leave as it is, and sin 2x can be written as 2 sin x cos x. So can we replace this one as using the identity, trigonometric identity? Can we replace this as cos square x plus sin square x plus 2 sin x cos x? Here we are replacing sin 2x using the trigonometric formula to sin x cos x, and to further simplification we are replacing this one as using trigonometric identity cos square x plus sin square x. So now this is of the form a square plus b square plus 2ab. So since we have a square plus b square plus 2ab, that can be written as a plus b the whole square. Numerator you have cos x minus sin x, and denominator you have cos x plus sin x the whole square. Either if you are writing sin x plus cos x the whole square or cos x plus sin x the whole square, both means the same because everything is in positive. So order of writing for sin or cos means the same. So nothing differs here. And here, to further simplification, we have to use the substitution method that we have learnt in the second exercise. Obviously, we will write or we'll take the denominator part as t. Let cos x plus sin x is equal to t. What will be the next step? Differentiating with respect to x on both sides. So cos x differentiation is minus sin x, and sin x differentiation is cos x, and t differentiation is dt by dx. Since you have cos x minus sin x, and here also you got the same thing, take this dx to the right side. So I am just writing the positive term first, negative term next, into dx equal to dt. And now we are replacing in the given question as we have used the substitution method. So I is equal to, in place of cos x minus sin x dx, we found it as dt, and in place of cos x plus sin x we have taken it as t, and you have it in power. So whenever it is in power other than 1, take it to the numerator as in the opposite sign. If it is positive, you will be writing in negative. If it is negative, if you are taking to the numerator, then that will be positive. So power rule, you will be adding 1 to the new power by minus 2 plus 1 plus c. Replacing t, and here you will get the negative power, isn't it? I hope you all remember when we work out the 7.2 exercise. And here replacing t as cos x plus sin x, and since it is minus, so here also denominator you have minus, so minus 1 by, in place of t it is cos x plus sin x, power 1 you can leave like as it is, plus c. This is the required answer. Any doubt? Can we move on to the next question? What is the next question? tan cube 2x into I equal to tan cube 2x into secant 2x dx. What is the next step? What we have to do? What we have to do? So I'm just rearranging this tan cube as tan square 2x into tan 2x secant 2x dx. That is for our easier convenience. So now replace this tan square 2x as identity using the trigonometric identity secant square 2x minus 1 into tan 2x secant 2x dx, because here we have tan and secant in product. If I take tan as t, you will get it as secant square. But what we have as a term, tan into secant. So if I take tan as t, I can't substitute here. That will be the question, because you can have tan cube as it is. You can have tan cube as it is. You can take tan 2x as t and you can find the derivative. If the question is tan cube 2x into secant square 2x, you can directly take tan as t and you can do the substitution part. But here the secant power is 1. So if you take tan as t, you will get the derivative as secant square, but we have only power 1. So it is difficult for us if you take tan 2x straight away as t. So we are replacing in terms of secant, so that if you take secant square x as t, you will get the differentiation of secant as secant into tan. So it will be easy to substitute. So for that reason, we are converting or using the identity, we are expressing tan in terms of secant. Now the assumption, let secant square 2x minus 1, straight away you can take that as t, or simply secant square 2x. And now differentiating both sides with respect to x on both sides. So using the power rule, that will become 2 secant 2x. Now we have used the power rule. Then differentiation of secant 2x is secant 2x tan 2x equal to dt by dx. Now if you take secant square 2x as t, there is a problem. Why? Because we are getting 2 secant x. So what we have to take? So we have to take secant x as t, so that you will not end up with any problems in substituting back. So secant 2x, so secant differentiation is secant 2x tan 2x, and differentiation of 2x is 2 equal to dt by dx. Therefore, secant 2x tan 2x into, take this dx to the left side as into dx and into 2 to the right side as by 2. Why I have straight out here? Because if you straight away take secant square 2x as t, you will end up with 2 secant square 2x into tan x. But what we have here, only tan 2x and secant 2x, that is the power of secant is 1. Here we are ending up with 2, that is not, like, we can't substitute there as the power varies. So to avoid that confusion, we are taking only secant as t, so that it is easy for us to substitute and integrate. Is it clear? Now the question becomes I equal to In place of secant 2x is t. We have power 2. So t square minus 1 as it is. In place of tan 2x secant 2x dx, it is replaced as dt by 2. So I'm just writing it as by 2, or you can take it outside. So 1 by 2 integral t square minus 1 into dt. Now integrate with respect to t. So t cube power ulliya. So t cube by 3. Just multiply 1 by 2 integral dt to 2 terms. So already we have 2. Here we'll get the power 3. So 2 3s are 6 minus t by 2 plus c. So the required answer will be replace t in terms of x, that is secant 2x power 3, the whole power 3 by 6 minus secant 2x by 2 plus c. This is the required answer. Any doubt in this? If you have any doubt, please post it in the comment section so that I can explain again if you need. Or if you want me to wait for some time so that you can work out, or you can take the screenshot also, I can wait. Just put it in the comment box, whatever you need. Okay. So assuming that you understood this, I am moving on to the next question. Question number 16. Tan power 4x dx. So question number 16. I equal to integral tan power 4x dx. Just as usual, rearrange the terms. I am writing it as tan square x into tan square x, or tan square x the whole square, whatever way. I am just writing in this form, and replace 1 tan square x using the trigonometric identity as secant square x minus 1. Multiply this tan square x inside. So tan square x secant square x dx minus tan square x dx. And here you can use the substitution method, and here again you have to use the trigonometric identity. I am just writing as it is so that the next term I can write in simplified form. So minus secant square x minus 1 into dx. Now use substitution method for the first term. So what you get here? Here, like if you take secant x as tan t, then you have to get secant x tan x. Yeah. So we'll take tan x as t. So let tan x equal to secant x also I can take. That is also fine. Secant x tan x will get it, yeah. But you have tan square x, so that will be difficult for us because we can't get tan square x when you take secant x as t. So we are taking tan x as t. Differentiating both sides, you will get secant square x dt by dx, and take this dx to the left side, so it will become secant square x dx equal to dt. So this will become dt, and tan square x, tan x is t, so it is t square dt minus, just split the terms, secant square x dx minus into minus plus 1 into dx. So t square can be written as, when you integrate t cube minus 3, t cube by 3 minus secant square x integration is tan x and dx integration is x. Replace t in terms of x, so that will be tan x the whole cube or tan cube x, both means the same. So tan cube x by 3 minus tan x plus c. This is the final answer. Any doubt in this? Any doubt? Can we move on to the next question? Question number 17. I equal to cos 2x. This is question number 18. Let's do this first, then we'll move to the 17th question. So cos 2x plus 2 sin square x by cos square x dx. Straight away, we can use cos 2x as, since we have sin squared x term. So cos 2x can be replaced as 1 minus 2 sin square x. Just we are using the formulas only. Plus 2 sin square x by cos square x dx. What happens here? Minus 2 sin square x plus sin square x gets cancelled. We have only 1. So 1 by cos square can be written as secant square x. And we know the integration of secant square x is tan x plus c. That's all. Very simple, right? Just you have to know the formula. If you know the formula, then it will be easy. Next, question number 19. We have left out 17. Sorry, ma. 17 we'll do here. I equal to integral sin cube x plus cos cube x by sin square x cos square x dx. Just split the terms. So it will be sin cube x by, because denominator we have in product, yeah? So it will be easy for us to cancel the terms as everything in terms of sin and cos. So we will find it easy as denominator is in product. Now if you see sin cube x, so 1 sin x will be in the numerator, sin square x gets cancelled. Here 1 cos x will be in the numerator, cos square x gets cancelled. Now you have this cos square, I am rearranging it as cos x into cos x. So that sin x by cos x, because two terms I have, into 1 by cos x dx plus the next term as it is sin square x, I am replacing it as sin x into sin x, so that it is easy for us to combine the terms and you also will not get confused how many terms you have used. Okay, and now one term sin x by cos x can be written as tan x, 1 by cos can be written as secant x. Similarly, cos x by sin x can be written as cot x and 1 by sin can be written as cosecant x dx. Just we are using the reciprocal relations of trigonometry and just we are writing. That's all. So now using the formula, integral of tan x secant x is secant x. Integration of cot x cosecant x is minus cosecant x. So plus into minus will become minus cosecant x plus c. This is the required answer. We have just splitted the terms. We used the reciprocal relation that you have learnt in class 10 and we have used the integration formula straight away. That's all. Any doubt in this? If I am going very fast, please put a message so that I can reduce the speed, or if this is okay, whatever it is, please put a message if anything is not convenient according to you. Okay. Question number 18 already we have worked out. So now question number 19, 1 by sin x into cos cube x. So what we do is we are multiplying and dividing by cos x in the denominator alone. So multiply and divide by cos x in the denominator, because if you take it to the numerator, it is difficult for us to solve. So multiply and divide by cos x in the denominator. I have just written a chart. So integral 1 by, so this multiply and divide, yeah? So that divide term I combine with sin x, multiply term I combine with this cos cube x. So cos cube x into cos x will become cos power 4x. Sin by cos will become tan x. So that can be written as 1 by tan x into cos power 4x dx. And we know the reciprocal relation. How we can do this question? So take this 1 by cos power 4 as secant power 4. Instead of writing directly, I am writing secant square x into secant square x by tan x dx. Replace secant square x as 1 plus tan square x so that it is easy for us to use the substitution method, and take tan x as t. So when you take, because in denominator you have tan, and when you take tan x as t, when you find the derivative, you will get the secant square x. So it is easy for us to substitute. So let tan x equal to t. Differentiating on both sides with respect to x, you will get it as secant square x dx is equal to dt. So now in this place, you will be writing it as dt. So this given question can be written as I equal to integral 1 plus tan x is t, so it is 1 plus t square. Secant square dx is dt, the whole by tan x as t. Now we can split the terms, so it is 1 by t dt plus t square by t dt. 1t gets cancelled. 1 by t integration is log t, and t integration is t square by 2 plus c. So log, in place of t, you can write what we have assumed, that is tan x. So log tan x plus tan square x by 2 plus c. This is the required answer. Just we have multiplied and divided by cos so that it is easy for us to obtain tan and secant, so that you can use the substitution. Because sin x and cos cube, we can't do anything with that. Okay. So to avoid any confusions, and numerator if you take, then it will be difficult to do the substitution part. So for that, our convenience, not to get so much of confusion, we have only multiplied and divided in the denominator alone. Okay. Then combine, use the reciprocal relations, whatever you have learnt in the previous classes, use the formulas of integration and integrate. That's all. Any doubt in this? Can we move on to the next question? Question number 20. Sorry. Question number 20. I equal to integral cos 2x by cos x plus sin x t whole square dx. Okay. Since you have square terms like cos and sin in both numerator and denominator, we can replace cos 2x as cos square x minus sin square x, the whole by cos x plus sin x, the whole square. Now replace the algebraic identity, or use the algebraic identity. In place of a you have cos x, in place of b you have sin x. So it is of the form a square minus b square. So that can be written as a plus b into a minus b, the whole by cos x plus sin x, the whole square, into dx. So one term as a whole gets cancelled, and we'll end up with cos x minus sin x by cos x plus sin x into dx. Okay. We'll take the substitution method. That is how we can integrate. As usual, take the denominator part. So let cos x plus sin x equal to t. Differentiate both sides with respect to x. So minus sin x plus cos x equal to dt by dx, and I'm writing the plus terms first. So cos x minus sin x as a whole into here it is dx. So dx equal to dt. Now replacing the given question, in place of cos x minus sin x into dx, you can write it as dt, cos x plus sin x as t. So using the formula 1 by t dt as log t plus c. Replace t in terms of x. So you have log of cos x plus sin x plus c. This is the required answer. Any doubt on this? So totally we have 22 questions in this. We have completed 20 questions. Any doubt? Question number 21. I equal to integral sine inverse of cos x dx. So we have to express in terms of sine inside so that you can use the inverse property. So sine inverse of, we can use the complementary angle. That is, I will get sine of 90 minus theta if I have, you will get it as cos x. So just you are using the other way around. So cos x, in place of that you can write it as sine of 90 minus x dx. So now using the inverse property, inverse and trigonometry gets cancelled. You have integral. So I equal to integral. So pi by 2 is constant. You can take it out. So integral dx minus integral x dx. So integration of dx is x. So it is pi x by 2 minus x integration is x square by 2 plus c. This is the final answer. Question number 22 is like one of the important questions in this exercise, and also you have in similar question in the miscellaneous exercise also, so that you have to be careful. Question number 22, I equal to integral 1 by cos of x minus a cos of x minus b dx. So here it is very difficult for us to solve if you have in this way. So what we are going to do is multiply and divide by sine of a minus b. First let us, because you have x, a and b, yeah, we have 3 tasks here. You have to bring a, b and x. So it is easy to bring a and b first, because only one term we have at x. Now multiply and divide by sine of a minus b, because you have minus a minus b, yeah. So I am writing it as a minus b. And no x terms in that. In the question, the integrating variable is x, and no x terms in the argument. So only multiplication part we need, the division part we don't need. So that we are taking the division part outside. So 1 by sine of a minus b into integral sine of a minus b the whole by cos of x minus a into cos of x minus b dx. Okay. Now add and subtract x in the argument in the numerator. Add and subtract x in the numerator argument part. Okay, that you have to be careful. Now this will become 1 by sine of a minus b into, can you able to see, integral sine of x minus x, yeah. I'm just writing it as x minus b. I'm just writing that first, plus term x here, minus x I'm writing, plus a I'm writing lambda last, so that it is easy for us to combine. And denominator, if you check the angle, you have both the x as positive and both a and b are in negative. So combining the first two, it will be easy. And for the next two, take minus as common. Okay. So 1 by sine of a minus b into integral, and just combining x minus b as it is, and minus I'm taking out, so x will become positive, a will become negative. Now this is of the form sine of a minus b. What is the formula? What is sine of a minus b? Sine of a minus b is sine a cos b minus cos a sine b. So this formula only we are going to use here. So that will be 1 by sine of a minus b into integral, in place of a it is x minus b, in place of b it is x minus a. So I'm just splitting as two terms because you'll get it as two terms earlier. So now sine of x minus b into cos of x minus a the whole by cos of x minus a into cos of x minus b dx. In between you have minus, and I'm just writing 1 by sine of a minus b as a whole common, and integral cos of x minus b into sine of x minus a the whole by cos of x minus a into cos of x minus b into dx. Just put the square symbol. And if you see here, since everything is in product, it is easy for us to cancel the terms. So cos of x minus a gets cancelled, and here cos of x minus b gets cancelled. And since the arguments are same, that is in numerator you have sine of x minus b, and in denominator you have cos of x minus b. Since the arguments are same, you can use the relation. So sine by cos can be written as tan. So and the angle is tan of x minus b dx minus, here also sine of x minus a, cos of x minus a. That can be written as tan of x minus a dx. And I already showed you that you have four separate formulas, that is apart from the differentiation formulas that you have learned. Here you have integral tan x, that is already given. For integral tan x, integral cot x, integral secant x, and integral cosecant x. That four formulas given separately, as those things are not in your differentiation part. Okay. So tan x integration is log secant x. So now this can be written as 1 by sine of a minus b into integration of tan is log secant x. So log secant of x minus b minus log secant of x minus a plus c. And we know logarithmic functions, log of log b minus log a can be written as log of b by a. So here 1 by sine of a minus b into log of secant of x minus b by secant of x minus a plus c. This is the required answer. Furthermore, you can simplify here, that is 1 by secant can be written as cos. So this 1 by secant of x minus a can be written as cos of x minus a, and secant can be written as 1 by cos. Yeah, like you have 1 by secant can be written as cos, secant can be written as 1 by cos. Like anyway you will get it as thing. So 1 by, so here itself you can stop, or further classification, simplification, since you have sine. So log of The secant, this will be in the numerator part, and that will come to the denominator part, plus c. Since we have minus, we are multiplying and dividing by sign of a minus b, and multiplying and dividing by sign of a minus b. If you have plus in the denominator, then you will be multiplying and dividing by sign of a plus b by sign of a plus b. Okay, so that is the simplified answer. This is very, very important in the sense this, like, you can't just like that easily try to solve, because it is a product of two functions in the denominator. So whatever the way you try, the arguments are not same, so it will be difficult for you to, like, if you take 1 by cos a secant, like you have secant of x minus a, secant of x minus b, then also you don't have the formula as it is in product of two functions, right? So far we have had the questions as tan power 4x, secant power 4x, or sine power 4x, or sine power 3x. It means the angle is same throughout, like whatever how many terms you have. But here the angles are not same. It is different. If it is different and if it is in product form, it will be very difficult for you to use the formulas that you have worked out so far, because now only you are learning this. So since now only you are learning, and so far we have discussed only the same angle, it will be difficult to pursue in, like, in the methods what we have solved. So in order to avoid those confusions, we are taking, like, we are introducing a term in terms of sign, so that it will be easy for us to use that, because you can also multiply and divide by cos. Okay, if you multiply and divide by cos, what happens is you have cos of a minus b or a plus b, whatever it is, you'll have entirely in terms of cos, entirely in terms of sine. So when you split the terms, you have cos of x minus b, cos of x minus a by cos of x minus a, x minus b, sine of x minus b, sine of x minus a by, like, you can't again simplify, because that's a whole one term will get cancelled. And here when you come, you have both sine in the numerator, both cos in the denominator. Again there will be confusion, because if you will get it as tan of x minus a into tan of x minus b instead of secant. So that also will be difficult for us to do. There you will be like struggling how to do. So in order to avoid those confusions, we are using sine, because sine of a plus b or a minus b contains both sine and cos, so that one term will get cancelled when you split the numerator, and that will be easy to find the integration rather than doing by any other method. So out of all the convenient or all the possible methods, this is easy, as some terms is getting cancelled and it makes us to integrate in a easier way. Or if we carry out by substitution method also, that will be possible. Is that clear? This is very, 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 very important. And next, for the next exercise, you should know 6 formulas. Okay, that I will post it in the shorts, that you should specifically know, so that we can work out the 7.4 exercise. Tomorrow we will work out 7.4 exercise. Please post your convenient timings in the comment box, so that I can schedule the class accordingly. And I didn't expect these many students will turn out today and at this time, because now only I just posted, we'll have a live session, and 80 to 90 students have joined. That I didn't expect at all, because I didn't announce it previous, like I didn't give an information earlier, but still so many have joined. Thank you for your support. Please feel free to ask any doubts or whatever you need to be taught here. To, like, I'm ready to reteach again if you find it difficult. So please, whatever difficulty or whatever you need, post it in the comment section, so that I can do accordingly, or I can schedule accordingly. Okay. Thank you so much and good night, dear students. All the best.